To balance redox reaction, the first step is always to assign oxidation numbers. So, to every single element. When we take a look at dichromate here, the dichromate has to equal a total of -2. Now we start with the guy at the end. So I know that oxygen is a -2 charge. He'll follow his rules on the periodic table. So I know that a -2 times 7 is a -14. This whole compound, or this whole polyatomic, has to equal a -2. And I know that I have 2 chromates, so I'm going to call that 2x, since I'm just trying to figure out the charge of 1 chromate. Well, to make that work, I know that x has to equal 6. 6 times 2 is 12, minus 14 is a -2. So I know that chromate, or chromium here, is a +6. Now, in nitrous acid, it's a little easier. The whole compound here has got to equal 0, because it's not a polyatomic ion. Again, starting with oxygen, oxygen is -2. A -2 times 2 is a -4. But then, oh, I have 2 elements here, 2 more. So what I do is I deal with the guy in the middle as x, and usually the guy in the front and the guy at the end follow the rules. And so I know that hydrogen, the rules for the periodic table is +1. And so I know that I have a 1 plus x minus 4 equals 0. So easily I can see that x has to be a +3. So then chromium is already done. So it's +3, pretty easy. And then the same deal with nitrate, that the polyatomic is a -1. Oxygen's -2. So a -2 times 3 is a -6. So nitrogen is x, and so x is going to have to be a +5 here. So now I have all my oxidation numbers assigned. I'm going to make just a little chart that lets me see that if I go up the number line, then I know that my compound, or my ion or element, has been oxidized. So just if you remember that up starts with a vowel, oxidation starts with a vowel. So anytime you go up, you have lost electrons because you're becoming more positive. And anytime you've gone down, you're reduced and you're going to gain electrons. Or oil rig, oxidation is loss and reduction is gain. So it's all about this little electron. So what I'm going to look at now is I'm going to see who changed. And so I can see real quick that Cr went from a +6 to a +3. And so we're going to do this by half reaction method. So I'm going to write down the compound Cr2O7 -2, and I'm going to write down Cr +3. Now I need to decide what happened. So I know that Cr went from +6 to a +3. And so I need to balance that out. So a really quick, easy way to remember is that you always add the electron on the side that's more positive. So I'm going to scooch this over a little bit so I have a little bit of room. And because of that, because of the +6, to get it to +3, I need to add 3 electrons to make that work. So 3, a -3 plus 6 is a +3. And so I can also see that I went from a +6 down to a +3, so I know that this is my reduction half reaction. Sometimes it'll ask you to label that. So I have one main thing here, though. The last little check before I move on from this half reaction: is there any subscripts on the element that changed? And the answer to that is yes. There are 2 here, but there's not a 2 on the Cr +3, so I need to balance that out. So I need to multiply that by 2. So that means that each chromium is going to gain 3 electrons, and so I need to actually multiply this guy by 2. So that's going to be a total of 6 electrons that are being gained. So that now is the half reaction, the reduction half reaction. So if somebody gains electrons, someone had to lose. So that's why it's called redox, reduction oxidation. And so I'm going to look and see who else changed. So if I take a look, I can see that nitrogen went from +3 to +5. So I'm going to write down now that reaction. So I have HNO2, and that's going to yield some NO3, -1. And so nitrogen went from a +3 to a +5. So if I go back over here to my chart, I'm going now from a +3 up to a +5. So I can see that this is my oxidation half reaction, that my electrons have been lost. And again, taking a look, I have +3 and +5, and we write the electron on the side that's more positive to make it go down. So I have a +5 plus, in this case, 2 electrons. So +5 minus 2 is +3. And then I take a look, are there any subscripts on my element that changed? And the answer is no. So I don't have to do anything for that particular one. So now my next step is to make sure my electrons are balanced. I can't gain 6 electrons if I've only lost 2. So I have to balance out my electrons lost and gained. They have to be equal. So how can I turn a 6 and a 2 into the same number? Well, this one's pretty simple. I just multiply the whole reaction here. I'm going to multiply this whole reaction here by 3. So when I do that, I get that I have 3 HNO2s, and that's going to yield 3 NO3 minuses plus 6 electrons. So now my electrons match, which allows me to cancel them out. So I don't get confused. I'm actually going to take this reaction that I multiplied by 3 and just kind of exit out so that when I add them up, I don't add an additional compounds. So now what I want to do is just combine everything. So what are my reactants? Well, my reactants are 3HNO2 plus, go back up, it's my chromate, Cr2O7. And my products are 3 NO3s and my chromium ion, 2 Cr plus 3s. So I'm almost done. I have my elements that changed. I know who's oxidized and who's reduced. And I have one little problem. I still have some H's and O's that aren't balanced. And so since this reaction has told me straight out that it's in an acidic solution, you can see that it's in an acidic solution, there's a little step for that. That means it's floating around in some hydrogen ions. So to balance anything in an acidic solution, you have a little thing. You just, to balance your O's, you add water, and to balance H's, so O's, so I want to balance some oxygen, you're going to add H2O, and to balance your hydrogens, you're going to add H pluses. So to do that, I'm going to count up my oxygens, and so I'm going to have 3 times 2, so I'm going to have 6 oxygens from here, and I'm going to have 7 here, so that's a 13 total oxygens. So on this side, I have 9 oxygens, and so I need to decide, well, how many additional oxygens do I need? So I know that 9 plus 4 is 13, so I'm going to add 4 waters. So that's going to balance out my O's. And then my last step is I need to balance out my hydrogens. And so if I count those up, I have 3 hydrogens on this side. But on this side, I have 4 times 2. I have 8 hydrogens. So I know I need an additional 5 hydrogens. So I'm going to add 5 H pluses. So in doing that, that is my overall balanced redox reaction.